Alright, so this video will focus on 2.6. And if we look here, it asks for the perimeter and area. So I'm going to pause the video, or ask you to, and try to figure out the perimeter and the area of all of the various shapes. Alright, so here you go. The question is, how do the changes in dimension of similar geometric figures affect the perimeter and areas of the figures? So we'll start off with this here, and it says make pattern blocks. And we have make dimensions that are 2, 3, or 4 times greater than those of the original. So if I go through here and I have my pattern block, and if I make it 2 of these, how will that change things? So my area of this would now, or I'm sorry, my perimeter is 4 for my first one. If I had 2, I now would have a shape that would look kind of like, well, actually it would be double, so it would be like this. So I'd have 1, 2, 3, 4, 5, 6, 7, 8. And if I had 3, it would just keep on going. So every time it would get to be 4 more, right? So it would be now 12. If I looked at my rectangle, my original perimeter for my one rectangle would be 6. And then if I have 2 rectangles or 2 blocks, I now have 2 by 4 by 4 by 2, so that'd be 2, and then 4 would be 6, 8, and then I'd have 12, right? So this one would just go up by 2 every time, or so it'd be by 6 is what's happening. And we can keep on going. If I do 3, now I'm going to have 18, and if I have 4, of course I'm going to have 24. So it's just going up by 6. This is going up by 4 every time. And now it's saying, okay, so if we have this, what happens if you double the side lengths? And we have this before. It becomes 12, then triple is 18, and so on. And now we're going to find out the area if I do this. So instead of having my perimeter, we're now going to figure out the area. So like for instance, if this one, this would be a 2 by 2, which is a 4, 3 by 3, which is 9, and so on. And we do the same thing with the rectangle. Now what you're going to start to notice is that whenever you do perimeter, the perimeter is basically just whatever you have times it. So if let's say it's 4, and if you are doubling it, it would be 4 times 2, which equals 8. If you're tripling it, it would be times 3, and that equals 12. And that's great. But now the problem with things that we're going to have now is with area, that's 2-dimensional. So it's no longer going to be just a 1-dimensional object. And so we're going to get our dimensions, and we're going to have to square them, which you're going to see in just a moment. So it says here, work with a partner, look at the vertices, and we're now going to find the blue rectangle that is similar and has one side from -6 and label the vertices. So I have it right here. Here are my 2 vertices. If I look here, my rectangle, if I look at this goes up the long ways. 1, 2, 3, 4, 5, 6. And this also is 1, 2, 3, 4, 5, 6. It's basically just on its side is all that we're doing. So that's how we're figuring it out. Then we have to figure out my other 2. So if I look here, it's got to be 1, 2, 3. So I'm going to make this also 1, 2, and 3. And I put a dot here and a dot over here. And now it would be a similar rectangle. It says compare the perimeters and areas of figures and explain the results. So now we're going to actually show how that looks. So first of all, we're going to look at the perimeter of similar figures. So if they're similar, of course they have the same shape, maybe a different size. So here's a good example. So it says find the ratio of the perimeters from the red to the blue. So this is 4 to 6, right? So I can reduce that down to 2/3. So the ratio of the perimeters is 2 to 3. Got it? From red to blue. Pretty easy stuff. So now we're going to do this one here. Oops, sorry. So it says that it's 9 feet, and the other one is 15. So I'm going to reduce that down whatever I can. So it'd be 9 over 15 or 3 over 5 is the perimeter. Now we're going to look for the same thing, but for area. And for area, again, this is a two-dimensional thing. This is what I was kind of alluding to before. So it's length times width. So you're going to notice that it's going to change or be squared. So let's try this. So what's the ratio of this one here from red to blue? So in this case, it is, let me just get a new one here. So it is 6 to 10. But I could, of course, reduce that down to 3 to 5. But remember, this is going to be squared because it's length times width for area. So this would really be like 9 over 25. So the ratio of areas is 9 to 25. Again, I'm squaring it because it's not like the perimeter is one-dimensional. This is now two-dimensional. So I'll try another one. So it says the base of a triangle is 8 meters. The similar one is 7. What is the ratio of P to Q? So P is 8. Let's write that down. So I'm going to have 7 over 8. But of course it says area, right? And area we know we square. So this will be 49 over 64. Oh, I got it backwards. I apologize. What's the ratio of the area P of the area, of the area of P to the area of Q? And P is the 64, up top, and the other one's 49. I did it backwards. So it should be 8 over 7, or 64 over 49, whenever I square them. Bad too. All right, and the last one here is I have this this thing here that says a swimming pool is similar shape to the volleyball court. Find the perimeter and the area of the pool. So we know that the area is 200, the perimeter is 60. This corresponds to this right here, so 10 and 18. So I'm going to have 60 for the court, the perimeter, right? And then the perimeter of the pool is P. And the width of the court is 10. And we know that the width of the pool is 18. Now, there's a few things that this thing does, just so you know, that you could do this and it absolutely works. I don't see how it makes all that much sense. So what I do real quickly, I'll show you, is I put 60 over P equals 10 over 18. And I look for the scale factors, all that I'm doing. And this is essentially times 6, right? And this right here is also times 6. And when I do that, I get P equals 108. Now, the book does this thing called means and extremes, which is a really efficient way. It's going to take 10 times P and get 10P, and 60 times 18 and get 1080. And then when it divides through, it gets P equals 108. So it just does this means and extreme. It multiplies P times 10, which is 10P. 18 times 60 gets this. And then it solves for it. So P equals 108. And I got the same answer by just showing the scale factor. So it's up to you how you do it. This is definitely more efficient, but I think if you have to explain it later on, it gets more confusing. So now we're going to try the next one for the area. So we have the area now is 200, right, over A. And then we have our 10 over 18. And of course, these are squared. So I'm going to rewrite this. And I'll rewrite it as 200 over A equals 100 over 18 times 18, that's 364, is that right? What's 18 times 18? Oh, 324. All right, so I'll have 324. So again, there's a few ways to do this. You could go through and figure out that the scale factor here is times 2. And this would be times 2. So in this case, it would be 648. But it's going to do the means and extreme where it takes 100A and this here. And 648 gets the same answer I got, just a different method. So again, I show scale factor. It does the means and extreme. So here is one more problem for you. There's the answer. And